Good morning everyone. So welcome back to the class. So in the last session, I have derived various derivations. Now what I have done is, what are all the derivations that I have done and what was the final results? I have tabulated in a single board. I want you people to note it down. So the first one, it is the rectangle. So about x axis, about y axis and about the base AB. So here I need to write the base AB. This is also base AB. So here also it is AB and here also it is AB. So please make a note of it. So please make a note of it. So I will be giving you a few seconds for you people. So just check it out. So all the derivation results I have tabulated on the board. So there are totally 5 different standard diagrams. So one is the rectangle, second one is the symmetric triangle, the third one is the circle, and the next one is the semicircle, and other next one is the quadrant of a circle. Okay. So now what I will be doing here is, I will be continuing with the problems on moment of inertia. So let me give you the side so that you people can note it down. Okay. So now, keeping this in our mind, so let us start solving the problems on moment of inertia. Okay. The theory part, it is over now. So let me concentrate on the numerical problems now. So let me rub this. So now we'll move on with the numerical problems in moment of inertia. So I have taken a problem here. Let me read it out. Find the moment of inertia of the figure shown below about its centroidal axis. About its centroidal axis. As they have asked us to calculate the moment of inertia about the centroidal axis, first we need to mark the centroid. Remember one thing, centroid and moment of inertia, they are interrelated. So if you know centroid, half of the procedure in moment of inertia is automatically known. So you should always study the centroid before going into the moment of inertia. Okay. So now let me move on. So this is the diagram that they have given. It's an I section. Okay. It's an I section. So they are asking us to calculate the moment of inertia of the figure shown below about its centroidal axis. So I want to calculate the centroid. So if you don't know the centroid procedure, so it is compulsory that you need to study that and then only you need to come here. Okay. So first, so let me go with the centroid procedure. First, mark the coordinate axis. Mark the coordinate axis. Coordinate axis is nothing but x axis and y axis, and you need to mark it in such a way that the entire diagram should lie within that particular axis. So that's why I will be marking the y axis here. So I will be marking the y axis here. You should mark the coordinate axis in such a way that the entire diagram should lie within the x and y axis like this. Now this has become the origin now. Okay. So next, what is the second step in centroid? So check whether the diagram is having any axis of symmetry. Check whether the diagram is having any axis of symmetry. So I want you people to just check it out. If I draw XX line, will the diagram get divided into 2 equal parts? No. Okay. So only in the YY axis we have the axis of symmetry. So we'll write a line. The given diagram is symmetrical about YY axis. First let me mark the YY axis. So let me mark the YY axis. So the given diagram is symmetrical about YY axis. Therefore, whenever you have symmetry, directly you get the value of centroid. If you have YY axis of symmetry, you get x bar. If you have XX axis of symmetry, you get y bar. In this particular diagram, you have YY axis of symmetry. So you people will get x bar. So what is that x bar? What is the total value? 300. What is half of it? It is 150. That is 300 by 2. It is 150 mm. 300 by 2. It is 150 mm. I got that particular value. So x bar I have calculated it. If I want to mark the centroid, I want one more. So what is that? It is y bar. X bar I have calculated it. I need y bar. So let me proceed further to find y bar. So heading to find y bar. If I want to calculate y bar, so first I need to calculate the area of this particular diagram. I want you people to remember the centroid. So there you people have derived the expression for the standard geometrical diagram. Whether you people have derived an expression for an I section? No. You people have derived an expression for rectangle, symmetric triangle, right angle triangle, quadrant of a circle, semicircle, sector of a circle, like that. Yes or no? Now we have an I section. I don't have any formula for an I section. So what I will be doing is, I will be dividing the composite area into component area. I will be dividing the composite area into component area. How I will be dividing it? Observe. I will be drawing a line like this. So this will become the first part. Let me mark the centroid of that particular part. Let me call it as G1. Let me draw one more line like this. So this has become the second part, and I will be marking the centroid as G2. This has become the third part, and I will be marking the centroid like this, and this is G3. So totally how many component areas we have? We have totally 3 component areas. Why I have divided it? Because while doing it in the centroid, I don't have any expression for the entire I section. I have the derivation only for standard geometrical diagrams like sector of a circle, quadrant of a circle, semicircle, symmetric triangle, right angle triangle, then the rectangle. Yes or no? So that's why I have divided it like this. So first let me calculate the area of each part. So area of each part. So it's area of each part, I will be calculating it. So one by one let me go with it. So what is A1? So A1 is nothing but this 200 into 10. It is 200 into 10. That is 2000 mm square. It's 2000 mm square. Let me go with A2. So the second diagram, it is 300 into 10 or 10 into 300. That is 3000 mm square. Let me go with the third one. So third one, it is A3, which is nothing but equal to this 300 into 10. 300 into 10. That is also 300 mm square. Let me calculate the summation of all this particular area. Summation A is equal to A1 plus A2 plus A3. So it is 2000 plus 3000 plus 3000. So how much is that? It is 8000 mm square. It is 8000 mm square. Yes or no? So now let me calculate y bar. So if I want y bar, how many components we are having? We totally have 3 components, 1, 2 and 3 components. So it is A1 y1 plus A2 y2 plus A3 y3 whole divided by sigma A. Sir, you have not derived this derivation at all. Where you got this? It's not in this particular chapter. It is not from this particular chapter. It is from the centroid chapter. So that's why I'm telling you people, if you want to understand the moment of inertia, it is compulsory that you need to study the centroid. Okay. So now what I will be doing here is, so I know A1, A2, A3, sigma A. Everything I know it here. Yes or no? I know each and everything. The only things that are unknown there are y1, y2 and y3. So first let me calculate what is y1, what is y2 and what is y3. So let me go with y1. So what is that y1? Observe. It is the distance between the centroid of the concerned diagram till the reference axis. Which is our reference axis now? x-axis and y-axis is the reference axis. I want the y value, vertical value. If I want the vertical value, I need to touch the horizontal line. So that's why. You'll know, observe here. So from the centroid of the Kernson diagram till the reference axis. So from here to here, I want the distance. What is the total distance? So 10 plus 300 plus 10. So it is 320 is the total. Out of which deduct this. How much is this? Half of 10, that is 5. So can I say it is 320 minus 5? Yes, of course. So it is 320 minus 5. So how much is that? It is 315 mm. Next, let me go with y2. So how much is y2? So y2, it is the distance between the centroid of the Kernson diagram till the reference axis. So from here till here, I want the distance. So what is this total distance? 300. Then what is the distance from here to here? It is 300 by 2 will give me this particular distance. Plus 10. So from here to here, how much is that? It is 300 by 2 plus 10. So how much is that? It's 160 mm. Yes or no? So next, similarly, let me go with y3. So what is y3? It is the distance between the centroid of the Kernson diagram till the reference axis. So total we have 10. So from center till here, don't you think that it is 5? Yes. So it is 10 by 2, that is 5. So let me substitute back all these things in that. So y bar is equal to, what is A1? A1 is 2000 into y1 is 315 plus A2 is 3000 into y2 is 160 plus 1 more is A3 is 3000 into 5 divided by, what is sigma A? So sigma A is 8000 mm square. So after solving this, what is the value that we are getting it? So y bar is equal to 140.62 mm. 140.62 mm. So please remember one thing. While calculating the moment of inertia, if they are asking us to calculate it about the centroidal axis, so first you need to calculate the centroid. Okay, then only you can calculate the moment of inertia. So now let me mark this y bar in the main diagram. So let me do that. So from the base, I always need to mark it. The reason is, this is x-axis, this is y-axis, and this is the origin, right? So from this point, I need to mark it. So what is y bar? It is 140.62. Yes or no? So let me mark it. So from here, observe, from here till here, let me calculate what is the distance. So this is 10, this is 150 because total is 300. From center it is 150. So 10 plus 150, 160. So from here till here it is 160. So what is the value that we have got? It is 140.62. So can I mark x axis below this particular line and let me mark this particular value. What is this value? So it is y bar. So what is that y bar? It is 140.62. 140.62 mm. So what I suggest usually is, as soon as you people know this is 140.62, just mark the remaining distance. So what will be this particular distance? So total is 320. Yes or no? 320 minus, so 320 minus 140.62, it is 177.38. It's 177.38 mm. So where the x axis and y axis are meeting, that point is called as the main centroid. About this particular line only we need to calculate the moment of inertia. So any doubts in calculating the centroid? If not, let me move on with the calculations of moment of inertia. So let me start with that. So now let me start with the calculations of moment of inertia. So now to find the moment of inertia, moment of inertia. Here also we have two. One is about x-x axis and one more is about y-y axis. So first let me go with x-x axis. So it is Ixx I am in need of. So the formula is, remember parallel axis theorem? So it was IAB about the base is equal to Ixx plus AH square. Here also it is the same. Ixx is equal to IGX plus AH square. Okay, so let us keep this particular formula in our mind. Now what I will be doing is one by one I will be taking it up. So observe, Igx is nothing but the moment of inertia of that particular area. Okay, let me go one by one. Let me take up the first diagram. What is the shape of the first diagram? It's a rectangle. Yes or no? Yes, it's a rectangle. For a rectangle about x-x axis, what is the moment of inertia formula? I want everyone to go back and check out the tabular column that I have given there. So there I have mentioned it clearly. What is the moment of inertia of a rectangle about the x-x axis? It is BD cube by 12. So Igx is nothing but BD cube by 12. B is the horizontal distance. It is 200 into D cube. It is the 10 cube by 12 plus. What is the area? How to calculate the area of this? We already know it. A1. What was A1? 200 into 10, that is 2000. Into now, this is very important. What is that H? So everywhere we have discussed. It is the perpendicular distance between the two parallel lines. So here, which parallel line I need to consider? Observe here. I want everyone to concentrate. So it is the distance between the centroid of the Kernson diagram till the x-x axis, not the reference axis, till the x-x axis. It's very simple. Centroid of the Kernson diagram till the x-x axis. I want this particular distance. How to calculate this? It's very simple. What is this total distance? From this centroid till the top, it is 177.38, right? But where I want? From the centroid till here. So it is 177.38 minus 5. It's 177.38 minus 5 and make it square. So this is the first one. Plus. Because I have two more diagrams. Yes or no? This is the vertical diagram that I am in need of. So next I will be going same formula. Formula will not change. Here also the same thing. It's a rectangle. So for a rectangle about x-x axis, what is the moment of inertia formula? BD cube by 12. BD cube by 12. So what is B now? 10. What is D now? 300 cube by 12 plus AH square, area, breadth into depth. So that is 3000. Into now the important things comes into picture. What is that H? It is the distance between the centroid of the Kernson diagram till this reference axis. I want everyone to stop writing and concentrate here. It is the, what is that H for the second diagram? It is the distance between the centroid of the Kernson diagram till the x-x axis, E distance. This particular distance I want. So how to calculate it? It's very simple. Observe here. From here to here, what is that distance? Total is 300, half of it is 150. So it is 150 plus 10, 160 is the total distance from here to here, 160. But I know this distance, it is 140.62. So can I do it like this? Total distance is 160 minus 140.62. Yes. Total distance is 160 minus 140.62 and it will become square. Similarly, let me go with one more diagram. The bottom one. So here also it is same, it's a rectangle. For a rectangle about x-x axis, the formula is BD cube by 12. So what will happen? So B is, it is 300 into 10 cube by 12 plus area is 3000 into H square. Here also it is important now. It is the distance between the centroid of the Kernson diagram till the reference axis. So how to calculate this? It's very simple. So what is this total distance? It's 140.62. But I want it from this point. Do deduct 5. So 140.62 minus 5. 140.62 minus 5 and it is whole square. Solve it. So you people get 139.66 into 10 power 6. 139.66 into 10 power 6 mm to the power of 4, because the unit of moment of inertia is mm to the power of 4 or centimeter to the power of 4 or meter to the power of 4. Okay. So now you people have calculated Ixx, that is the moment of inertia about xx axis. Any difficulty in finding it out? I think this all, it's very simple. This particular distance you need to be very careful. So similarly what we will do here is, we have calculated the moment of inertia for Ixx. Let us calculate the moment of inertia similarly for Iyy. Okay. So I will be rubbing this part. So now instead of xx axis, I will be calculating the moment of inertia about y axis. Is that okay now? So it's very simple. So again, Iyy is equal to, let me take up the first diagram. So first diagram is a rectangle. About y axis, what is the formula of moment of inertia of a rectangle? It is db cube by 12. It is db cube by 12. So what is that d? So d is 10. db cube, b is 200 cube by 12 plus area is 2000, because 200 into 10, 2000 into h square. I want everyone to concentrate here. What will happen to h? What is that h usually? It is the distance between the centroid of the concerned diagram till xx axis. Here it is the centroid of the concerned diagram till the y axis. But here what happens is, observe, as we have the symmetry along y axis, don't you think that the centroid of the concerned diagram and the y axis, they are overlapping with each other? Here what was happening in the x direction? So from the centroid of the concerned diagram till the xx axis, I was having some distance. But as we have the symmetry along that particular direction, the centroid of the concerned diagram and the symmetrical axis, they are overlapping with each other. Therefore, it becomes 0. H is 0. Be careful. Whenever it becomes 0, our calculation will be easy. So similarly, let me go with that second diagram. So it is again db cube by 12. About y axis I am calculating. db cube, d is 300. db cube, 10 cube by 12 plus area into h. Area into h. What is that h? It is the centroid of the concerned diagram till the reference axis. They are overlapping with each other. Therefore, it becomes 0 plus one more. Again db cube by 12. So d is 10. b cube is 300 cube by 12 plus again what will happen to this h? 0. So after solving it, the Iyy value that I will be getting here is 29.19. It's 29.19 into 10 power 6 mm to the power of 4. So we are done with the first problem in the moment of inertia. We are done with the first problem in the moment of inertia. So any difficulty in finding it out? Please remember one thing. If they ask you people to calculate the moment of inertia about the centroidal axis, it is compulsory that you need to first find the centroid and then only you can calculate the moment of inertia. Any doubts in this problem? So if not, we'll continue with the next problem. So now I will be taking up the second problem in moment of inertia. Okay. So find the moment of inertia for the figure shown below about its centroidal axis. Here also they are asking us to calculate it with respect to the centroidal axis. Let us try it out. So as they are asking us to calculate it about the centroidal axis, the first thing that I need to do is mark the coordinate axis. So you should mark it in such a way that, so the extreme bottommost should be the x-axis, the extreme leftmost should be the y-axis. the extreme bottommost needs to be the x-axis and the extreme leftmost need to be the y-axis. So now what I will be doing, just check whether the diagram is having any axis of symmetry. Whether the diagram is having any axis of symmetry? No. So the diagram is neither symmetrical about x-x axis nor it is symmetrical about y-y axis. So it means that we need to calculate both x bar and y bar. There is no other option. But in the previous problem what happened? So we were having the symmetry about y-y axis, directly we got x bar. But in this problem we don't have symmetry on both the axes. We need to calculate x bar and y bar. Okay, we'll do that. So next, what is the third step in the centroid? Divide the composite area into component area. So here you can divide this diagram into, diagram in two types. So one is you can mark it like this or you can mark it like this. I will be doing it like this. I will be marking it like this, or else let me check it out. Yes, I will be marking it like this. Now this will be the first diagram and its centroid I will be calling it as G1. This will be my second diagram and I will be calling it as G2. Now what will be this particular distance? Total is 85, out of which I will be deducting 10. So this will become 75 mm. Now first let me calculate the area of each part. So first one, to find the areas. To find areas. So let me take up the first diagram, A1. So A1 is equal to breadth into depth, 10 into 125. So 10 into 125, it is 1250 mm square. Similarly, let me go with, so A2. So A2 is equal to, so please remember it is now 75 into 10, not 85, it is 75 into 10, that is 750 mm square. So let me calculate sigma A also. So it is summation of these two. So it is 1250 plus 750. So it is 2000 mm square. So now let me proceed further. I have calculated the areas of various components. Next, let me calculate the second one, to find x bar. To find x bar. So what is that x bar? So x bar is how many components you are having? Two components. Therefore A1 x1 plus A2 x2 divided by sigma A. I know A1, A2 and sigma A. The only two unknowns are x1 and x2. So where x1 and x2 I need to calculate it now. So let us check it out. x1. As I told you in the first problem, what is x? It is the distance between the centroid of the Kernson diagram till the reference axis. Till the reference axis. Let me concentrate here. So it is the centroid of the Kernson diagram till the reference axis. As I want the x distance, please remember this, I want x distance, okay? I want x distance. So x distance is nothing but, observe, so x distance is this one. So what is this distance? It is 10 by 2. So it is 10 by 2, that is 5 mm. Similarly, let me go with one more. So next, it is the centroid, it is the distance between the centroid of the Kernson diagram till the reference axis. Be careful now. So what is this total distance? 75. So from here to here, what is the distance? 75 divided by 2, that is 37.5. That will give me this distance, but I need till the reference axis. So the 75 by 2 plus 10. 75 by 2 plus 10. 37.5, that is 47.5 mm. So substitute everything. Okay. So now let me substitute all this in this x bar. So what will happen? So x bar is equal to, so what is A1? I know it. It is 1250 into, what is that x1? 5 mm plus, so what is A2? So A2 is 750 into, what is that second value? It is 47.5 divided by sigma A, it is 2000. So after solving this, the value that we are going to get here is, So x bar value it will be, so 20.94 mm. It's 20.94 mm. So I want you people to just cross verify whether the answer that I am writing it's correct or not. Okay. So now let me go with one more. So the next one is to find y bar. Same formula. So y bar is equal to a1 y1 plus a2 y2 divided by, okay, so sigma a. Let me take up, so what is y1 and y2? So let me calculate what is y1 and y2. So as the name itself indicate, y1, it is the vertical distance. So what is that y1? It is the distance between the centroid of the Kernson diagram. First diagram I am taking, centroid of the Kernson diagram till the reference axis. If I want the vertical distance, I need to touch the horizontal line. Centroid of the Kernson diagram till the reference axis. What is the total height? 125. Half of it, it is 62.5. So it's 125 by 2, it is 62.5. Okay. So now let me go with y2. So it is the distance between the centroid of the Kernson diagram till the reference axis. So I want from here till the reference axis. Total is 10. Half of it is 5. So it is 10 by 2, that is 5. So what will happen to y bar now? Therefore y bar is equal to a1 is 1250 into y1 is 62.5 plus a2 is 750 into y2 is 5 mm whole divided by, what is sigma a? 2000. So after solving it, so what is the value of y bar that we are going to get? So the y bar value is 40.94. It's 40.94 mm. So the first thing that we need to do here is, first let me mark the x bar and y bar value in the main diagram. Let me mark the x bar and y bar value in the main diagram. So now, so first let me go with x bar. X bar is 20.94. From the origin I need to start marking. Okay. So from here, so this distance is 10. What is till here? What is the distance till here? So this is 37.5 plus 10, 47.5. So from here to here it is 47.5. From here to here it is 10. So whatever the value of 20.94 that I have got, so it needs to be marked somewhere here. So it is y. Let me mark that particular value. So this value is nothing but the x bar value, and what is its value? It's 20.94. Soon after getting this value, what I suggest is mark the remaining distance. Mark the remaining distance. So its total is 85. 85 minus 20.94. 85 minus 20.94. 85 minus 20.94. So it is 64.06. It is 64.06. It is 64.06. Similarly, let me mark in the y direction also. In the y direction, it is 40.94. So from here to here, it is 62 point something. So 62.5. I want 40 point something. So it will be somewhere here. So I will be marking this as XX. The point where the two are meeting, that point is called as the centroid. And this vertical distance, let me mark it here. This is nothing but the y bar value. So y bar is 40.94. And what is the remaining distance? So what is that remaining distance? So that remaining distance is, total is 125 minus 40.94. So just a moment. So it is 125 minus 40.94. So it is 84.06. It is 84.06. So now we have marked the centroid. We have marked the centroid. So now what we need to do now? So we have to calculate the moment of inertia about x axis, and then we need to calculate the moment of inertia about y axis. So let us start doing that. So first Let me rub this part. So now let me take up the moment of inertia. So that is, I think it is the fourth step, I guess. So it is to find moment of inertia. So in that first one, about Ixx, the formula is Igx plus AH square. So let me take it. So let me take up the first diagram. So it's a rectangle, yes or no? For a rectangle, so what is the formula? It is BD cube by 12 about XX axis. B is 10, D cube is 125. So B D cube by 12 plus area 10 into 125. It's 10 into 125 into H square. So that is very important. What is that H square? Be careful now. It is the distance between the centroid of the Kernson diagram till the XX axis. Not XX axis. Observe, because I want everyone to concentrate here. Yes, I need to touch the XX axis. It is the distance between the centroid of the Kernson diagram till the XX axis. This distance I want. How to calculate it? It's very simple. Observe here. So what is this distance? Total is 125. Half of it is 62.5. 62.5 minus 40.94. So it's 62.5 minus 40.94 whole square. So next we have one more. So plus. We have one more. So it is again, it is BD cube by 12. What is B? 75. Don't take it as 85 because I have taken this particular diagram in the first diagram itself, this space. So it is BD cube, 75 into 10 cube by 12. It is 75 into 10 cube by 12 plus area is 750 into, what is that H square? It is the distance between the centroid of the Kernson diagram. Centroid of the Kernson diagram till which particular axis? I am calculating it about XX axis. What is the total distance? 40.94. But I want it from the centroid till here. So deduct 5. So it is 40.94 minus 5. 40.94 minus 5 whole square. So solve it. The value that you are going to get. So the value that you are going to get is 3.41 into 10 power 6. So it's 3.41 into 10 power 6 mm to the power of 4. Please cross verify these values because as I am not solving it, directly I am taking it from the book. So that's why I want you people to just cross verify that values. So Ixx I got it. Similarly, let me go with Iyy. Similarly, let me go with Iyy. It is nothing but Igy plus AH square. Igy plus AH square. So now what I will be doing, observe here. So it is about YY axis. Whenever you are taking it about YY axis, it is dB cube by 12. dB cube by 12. So what is D? So D is 125. D, B cube is 10 cube. So it is 125 into, so D, B cube is 10 cube by 12 plus area is 1250 into H square. In the last problem, in the YY axis, we were having the symmetry. That's why all the H value was 0 there. But here it is not that case. So we need to calculate it. It is the centroid of the Kernson diagram, okay, till the YY axis. This distance I want. It's very simple. What is this distance? It is 20.94. What is this distance? 10 by 2, 5. So 20.94 minus 5 will give me the remaining, will give me this particular distance. So it is 20.94. So it's 20.94 minus 5. So any difficulty in this? And it is square. Plus we have one more, right? So we have one more diagram. So it is this one. It is 75 into 10 cube, not 75 into 10 cube, sorry, dB cube. D is 10, B cube is 75 cube. So dB cube by 12 plus, what is the area? Breadth into depth, that is 750 into. So what is that distance? It is the distance between the centroid of the Kernson diagram till the reference axis. About which axis you are calculating it? About y axis. Be careful now. I want everyone to tell me what is this particular distance. So from here to here it is 37.5 plus 10, 47.5. From here to here it is 47.5, correct? Minus 20.94. So 47.5 minus 20.94 will give me this distance. So 47.5 minus 20.94 whole square. So try it out. You solve it. The value that you are going to get is IYY is equal to 1.208. IYY is equal to 1.208 into 10 power 6 mm to the power of 4. So they have asked us to calculate the moment of inertia. So about x axis also I have calculated, and about y axis also I have calculated. Now let me introduce some more things. Okay, let me continue with some more thing. If in the question, if they would have asked, find the polar moment of inertia for the below figure about its centroidal axis, then what you people were supposed to do? Please remember, for the same problem, if they would have asked you people to calculate the polar moment of inertia about the centroidal axis, nothing to worry. What does perpendicular axis theorem states? So note, to find polar moment of inertia, if they ask us to calculate from perpendicular axis theorem, what is IZZ? It is IXX plus IYY. Yes or no? It is IXX plus IYY. What is IXX? Just now we have calculated. It is 3.41 into 10 power 6 plus the one more is 1.208 into 10 power 6. So add these two, you will get that particular value. Let me check it out. It is 4.61 into 10 power 6. 4.61 into 10 power 6. So please remember one thing. So if they ask you people in the examination, find the polar moment of inertia, don't get confused. If they ask you people the polar moment of inertia, you need to calculate the moment of inertia about x axis and y axis. You just add those two, that is nothing but the polar moment of inertia. Okay? For the same problem, second thing, for the same problem, if they ask you people to calculate the radius of gyration, that is also very simple. What is that? I think you people remember the formula. What is kxx? Which is nothing but equal to square root of Ixx by capital A. So Ixx, just now we have calculated it. So what is that Ixx? So Ixx value, it is 3.41 into 10 power 6 divided by, what is that capital A? That capital A is nothing but sigma A. So what is that? 2000. So I want you people to calculate that. Okay. Similarly, kyy is equal to square root of Iyy by A, which is equal to square root of 1.208 into 10 power 6 divided by capital A, it will be same 2000. You people solve it for this. By chance in the question, if they ask you people to calculate the polar radius of gyration, then also no need to panic. So polar radius of gyration, So what you need to do? So polar radius of gyration kzz is equal to square root of Izz by capital A. What is Izz? So it is 4.61. So it's 4.61 into 10 power 6 divided by 2000 is the area. So whatever the value that you get, that will be the polar radius of gyration. See, in a single problem, I have explained you people many concepts. Okay. In the examination, polar radius of gyration is asked, you need to calculate IZZ. If you want to calculate IZZ, you need to calculate IXX and IYY. Okay. So, in the single problem only, I have explained you people many concepts. So, I will be moving on with the next problem. Find the polar moment of inertia for the plane area shown in figure about the centroidal axis. So, I think the third problem, find the polar moment of inertia, find the polar moment of inertia, find the polar moment of inertia for the shaded area shown in figure about its centroidal axis, Okay. So, we will solve this problem now. So, let me take up the problem. So, the width they have given it as 200 mm. Next, the depth they have given it as 400 mm. Next, they have given a circle. And the diameter they have given it as, the diameter of the circle they have given it as 100 mm. And from the center of that particular circle, so to the top, it is placed at a distance of 100 mm. And this is the shaded region. So, now what I will be doing here is, so I will be deducting this particular cutout, because they have asked us to calculate the shaded region moment of inertia, not this particular circle. So, what I will be doing is, I will be taking the entire part first, then I will be deducting this circular cutout. So, let me check it out how we will be doing it. So, find the polar moment of inertia for the shaded area shown in figure about its centroidal axis. They are asking us to calculate the moment of inertia about the centroidal axis. So, there is no other go. So, what I need to do here? So, I need to calculate the centroid. So, first let me mark the coordinate axis. So, extreme bottommost is the x-axis and extreme leftmost is the y-axis. Correct? Next, I want you people to tell me what is the second step in the centroid? Whether the diagram is having any axis of symmetry. Yes, the diagram is having the axis of symmetry about y-y axis. About x-x axis it is not having. About y-y axis you have an axis of symmetry. Let me mark that. So, the diagram is having the y-y axis of symmetry. So, whenever we have the y-y axis of symmetry, we directly get the value of x bar. What is the total horizontal distance? 200. Out of half of it, it is 200 by 2, that is 100 mm. So, x bar we directly got it. So, what is the one more thing that I am in need of? Y bar. Okay, next. Let me go with the next step. We have two areas, standard areas. One is a rectangle and one more is a circle. So, what I will be doing is, this entire rectangular part, I will be considering it as the area 1. And its centroid lies exactly at the center. I will be calling it as G1. So, second diagram, it's a circle. I will be calling it as 2 and its centroid lies exactly at the center, and I will be calling that particular distance as, that centroid as G2. So, first let me calculate the area of the component areas. So, first one, to find areas. So, let me calculate A1. So as I have taken the A1 as the rectangle, so it is breadth into depth. So that is 200 into 400. So it's 200 into 400. So it is 8 and 1, 2, 3, 4. It is 80,000 mm square. Similarly, let me go with A2. So I think you people remember. So for the calculation of area of a circle, the formula is pi r square. As they have given the diameter, it is pi into. So it is pi d square by 4 or pi r square, anything is okay. So pi by 4 into d square, let me take it out. So it is 100 square. So let me check out what is the value for that. So the value is pi d square by 4. Let me calculate it and tell you people. So it is 7850 mm square. It is 7850 mm square. Now I need to calculate summation A. So please be careful now. I don't want this circular cutout because they are asking us to calculate the shaded area. So what I will be doing, A1 is the entire area including the circle I have taken. So what is that? It is 80,000 mm square minus this A2, that is the cutout. So it is 7850 mm square. So what is the value that you people are going to get there? So it is 72,146 mm square. So it is 72,146 mm square. Let me check it out. Sorry, it is 72,150 mm square. Okay, so now I got sigma A. So next I need to find x bar. I have already calculated. What is the value of x bar? X bar value is 100 mm. So now let me go with to find y bar. So what is y bar? Y bar is equal to, be careful, how many components you are having? 2 components. So it is A1 y1 minus A2 y2. Sir, why minus? The reason is I need to deduct this particular part, sigma A. I know everything except y1 and y2. So let me calculate y1 and y2. So what will be the y1? It's very simple. It is the distance between the centroid of the Kernson diagram till the reference axis. I want the vertical distance. Vertical distance if I want, it means that I need to touch the horizontal axis. So from center till here, what is the distance? Total is 400, half of it is 200. So it is 400 by 2, that is 200 mm. Next, what is that y2? So y2, it is the distance between the centroid of the Kernson diagram. Before that, what is the total height? 400. If this is 100, what will be the remaining distance? It's 300, yes or no? Yes. So now what I will be doing? So y2. So y2 is nothing but the total distance. Please listen here. So y2 is nothing but, it is the distance between the centroid of the Kernson drawing. It is the distance between the centroid of the Kernson drawing till the reference axis. Okay. So now what is that particular value? So from here to here, what is the distance? Just now we have calculated. It is 300. So it is 300 direct value. So let me substitute everything in y bar. So y bar is equal to A1. What is that A1? 80,000. So 80,000 into 200 minus, be careful, A2. It is 7850 into, so it is y2 is 300 whole divided by, so it is 72150. So I want you people to solve it out. So whatever the value that I am having it here, let me write it down. You people just check it out whether it is correct or not. As per my book, it is 210.9, but I want you people to check it out once. It's 210.9, okay, and it is mm. So let me mark this particular value in the main diagram. So y bar means the vertical distance. So from the reference axis, let me mark 210.9. So what is this distance? Total is 400, half of it is 200. But what is the value that I want? It is 210.9. So somewhere exceeding this point. I don't know where it exactly at, but for time being let me mark it here. So now this particular distance, I will be calling it as y bar. So if this is y bar, what is that value? It is 210.9. Soon after getting this, let me mark the remaining distance. So it's 400 minus 210.9. It's 400 minus 210.9. So 400 minus 210.9. It is 189.1. It's 189.1. Right? It's 189.1. Okay. So now I got the x bar value, now I got the y bar value. Where the 2 points are meeting, that particular point is the capital G. Okay. So now let me calculate the moment of inertia. Let me calculate the moment of inertia. Let me rub all these things. So now to find the moment of inertia, So next step, to find moment of inertia. So let me calculate it. So I want Ixx, it is nothing but equal to Igx plus AH square. Yes or no? So now let me go with one by one. So now the first diagram is a rectangle. So it is BD cube by 12. B is 200. Sorry. So B is 200. B D cube, it's 400 cube by 12 plus area I know, it is 80,000 into. So what is the area? Sorry, into h square. What is that h square? It is the distance between the centroid of the concerned diagram till the reference axis. I can easily find it out. What is this distance? 210.9. And what is this distance? 200. So 210.9 minus 200. 210.9 minus 200 whole square. Minus, you should not put plus now. So it is minus. One more. Why minus? I need to deduct this circle, no? That's why. So now it is about x axis. What is the formula? So just refer that particular tabular column that I have given. It is pi d4 by 64. So about x axis it is pi d4 by 64. It is pi into d, pi d4 by 64 is Igx plus area. So area, second area, I think I calculated it, I guess. It's 7850. It's 7850 into, please remember the concept, it is the centroid of the concerned diagram till the reference axis. So I know this distance, it is 189.1, yes or no? And what is this particular distance? 100. So it is 189.1 minus 100. 189.1 minus 100 whole square. So I want you people to solve it. So I will be writing the values that I am having it in my book. So it is Ixx is equal to 974.66. 974.66 into 10 power 6 mm to the power of 4. 10 power 6 mm to the power of 4. Please cross verify with these values. So next, similarly, let me go with Iyy is equal to Igy plus AH square. So what is Igy? So Igy is, as it is a rectangle, the first one, it is dB cube by 12. So what is D? D is 400. dB cube by 12 plus, what is the area of the first diagram? It is 80,000. Please change here. It is not 8,000, it is 80,000. Please make a correction here. It is 80,000. So it is 80,000 now into. So I want, it is the distance between the centroid of the concerned diagram till the reference axis. About which axis you are having the symmetry? About y axis only. About the y axis, as you are having symmetry, it is 0, minus, you have one more. So it is again about, for a circle, whether it is about x axis or it is about y axis, it is pi d4 by 64 is the value. It is pi into d4, that is 100 to the power of 4 by 64 plus 0. Why? A into h square, h is 0 because of symmetry. So solve it and get me the value. So as per the book, it is 261.75. It's 261.75 into 10 power 6 mm to the power of 4. Please cross verify with the values. Okay. So now I got Ixx, I got Iyy. They are not asking us in the question the moment of inertia. They are asking us for the polar moment of inertia. No problem. So Izz they are asking us polar moment of inertia, which is given by Ixx plus Iyy from the perpendicular axis theorem. Ixx, just now we have calculated it. It is 974.66 into 10 power 6 plus, let me go with one more, it is 261.75 into 10 power 6. So after adding these two, the value that we will be getting here is 1236.42. 1236.42 into 10 power 6. See, we are done with the polar moment of inertia also. So remember one thing, if they ask you people the polar moment of inertia, first you need to calculate the moment of inertia about x axis and moment of inertia about y axis. So I will be winding up the session here. I will be continuing it further later. Thank you.